Last week we learned about the packing and unpacking, and it's on the explanation. When you are doing the packing, you want to put the data into a tuple. So if you just put the data and then separate all the elements by comma, you will get an automated packing of a tuple. And if you have data, let's say the data is a range from a number 7 until 11, it means we are going to have number 7, 8, 9, and 10. So there are 4 numbers. And in order to put each of the value, we are preparing 4 variables. So the numbers will be assigned automatically to each of these variables. And yeah, this is what we call as the unpacking. In Python, beyond the built-in definitions, the standard Python distribution includes perhaps tens of thousands of other values. So there are many libraries, okay, we call it libraries, because it contains many values, functions, classes that already organized in one library. Okay. And usually we call it as modules. We can use the word import to import those modules into Python. For example, if I want to use the library math, so I can just mention import math. Okay. Now, when we have other examples, I think you will learn many import functions. The existing modules in Python are as follows. Array. If you learn about list is array-based data structure. In a list, you can have many kind of objects. So you can have the integer, you can have float, you can have string. So you can have multiple kinds of data elements. But in array, we have integer. So if it is integer, then all the data elements is on the integer. If we define the array as a string, then we will have the data elements only strings. If we define the data elements are float, then all elements will be only float. We have another kind of modules like collections. So it contains some data structure and abstraction of the classes. Copy. In some cases, we can copy the object. For example, we have array and then we want to copy to another variable. We have heap queue, met, OS, random, RE, SIS, temp. Okay. So those are the existing modules in Python. We will learn those modules by the time, okay, not now, because we will selectively learn those modules based on the lecture. Okay. That's about the Python basic. So you already have the first and the second Python. Now let's go to the next. We are going to learn about the object-oriented. Python is an object-oriented programming language. And when you are dealing with this kind of object-oriented, you need to understand what is the meaning by object, and then what is the attributes or the properties of the object and how you can design the object-oriented design. The first is you need to understand why we need to understand the object-oriented programming. The goal is robustness, because some software may handle the unexpected inputs. When we have unexpected inputs with the object-oriented programming, it can explicitly define its application. So if you are making a calculator, of course you want to have the input numbers. If you have a kind of sales database, of course you want to have the input string and numbers. If you already have your program with the object oriented, then you can define what are the inputs. Adaptability. The software needs to be able to evolve over time in response to changing conditions in its environment. Once you set how the object will work in your program, you can expand the object in the object-oriented programming with some properties. And reusability. If you have the same code, but it has different kind of application, you can reuse it. For example, you know how to sell books. The bookstore might be similar with the restaurant in terms of sales. So we have the product ID, we have the product name, we have the quantity, and we have price. So they are similar in the data. So we can reuse some of the components from the restaurant into the bookstore. Or if we have some components in the bookstore, we can put it into the restaurant. In that case, we can reuse some of the object in other domains to be applied to in another domain. In the object-oriented programming, we need to understand some terminologies. We have object. Each object created in the program is an instance of a class. If you understand what we have in the table, usually we call it, this is one object. So one object is like one data. Or we call this is an instance. Each class presents to the outside world a concise and a consistent view of the objects. There are instances of this class. Without going into too much unnecessary details or giving other access to the inner working of the object. Let's say if I have this table, if a table of student, okay, this is the table related to students, then I can have, this is a class of student, and I might have the objects related to name. I have my other object related to, for example, address. Okay, I have another kind of object related to, for example, phone number. I have another object or instances related to, for example, GPA, and so on. Okay. Here, the class students should have the name, address, phone, GPA, but later on, you may have some kind of method to change the name or to change the address, to change the phone information, to change the GPA information. But we can define in one object-oriented programming. we define the class to specify the instance variables. So this is the instance variables. We have name, we have address, we have phone, we have GPA. We call this is data members. And the object contains as well as the methods known as the member functions. Let's say I would like to assign a method to change name. So if the students want to change their name, we can provide a method to change the student name. Let's say the students will be able to move from one house to another house. For example, the student moved from the dormitory to one room. Then we can provide also a method change address. If the student changes his phone, maybe the students move from one provider to another provider. He changed the phone number from KT to SK, for example. So we can have the method change phone number and so on. So we call this is methods. And yeah, some other literatures it mentioned as member functions. So for example, okay, we have a class and I would like to define it as a class diagram. Using the word class here to define the class name. Here I would like to explain the class person. And then we have DEF, def to define the method. So we learn this as function in the previous section. Now let's see if we have one class which is class person, we can define the class and then the class name is this person and then we put the column. And then we have the function. The first function is say hi. And then we have self. So let's suppose I will explain what is the meaning by self. And then we have the column because it is a control structure. And then we have the statement print, how are you? Let's see in the notebook, what can we see the result. Let me make a new notebook. Let me put the name as Python OOP. So it is about the object-oriented programming. Now I would like to define a class, a person, and then I have the def, say hi, and then I define one parameter which is self, and then I will make how are you? If you execute this code, we say we already create one class. So how we can execute this class? First, we need to make an object. Suppose we have one person, and the person one, we call it as T1. So the person one is an object of the person. We call the class name. And I would like to know the result if I want to execute one of the methods from this class. So if I press dot, you can press the tab button and it automatically creates the method that you already defined in that class. In this case, we have say hi. For every method in Python, we need to define the parentheses. So if you run this one, you will see how are you. Okay. When we have multiple objects, let's say I have P1, P2, P3, yeah, we can define and we can put the object name. Suppose P1 is person 1, P2 is the person 2, and P3 is person 3. So we can have 3 data or 3 objects. And whenever we call the method, we need to use the dot. The dot means it is the separator between the object and the method. If we call the say hi with the parenthesis, then we will see the result. How are you? A class serves as the primary means for abstraction in object-oriented programming. In Python, every piece of data is represented as an instance of some class. So we have the class name, which is person, and every piece of the data will represent as an instance. A class provides a set of behaviors in the form of member functions. Okay, so we already learned this one, and it is known as methods, with implementation that belong to all its instances. So the methods, it can be the method related to each of the variable or the method which is a general method. A class also serves as a blueprint for its instances, effectively determining the way that state information from each instance is represented in the form of attributes. Yeah, we can learn the attributes like what we learned the table before. Let's say if we have name, and then we have address, and so on. So these are the attributes. Sometimes in the other literatures, they mention fields. Yeah. Maybe other literatures, they mention it as instance variables or data members. They are referring to the same things. In Python, we have self-identifier. It's very unique because in Python, they have this self, but in other programming languages, they don't have such kind of this self-identifier. In Python, the self-identifier plays a key role. In any class, there can be possibly be many different instances, and each must maintain its own instance variable. Therefore, each instance store its own instance variables to reflect its current state. So the syntactically self-identifies the instance upon which a method is invoked. So when you define self, you can name, okay, and then you can have address, you can have phone, and then you can, let's say, the GPA. Okay. So whenever you have this kind of things, when you define self, self will indicate one instance. Let's say I want to indicate this row. When you define the self, Python can refer to the respective rows. If you go to the next row, yeah, when you put the self, then Python can indicate that you are now accessing the second row, and so on. That's why we need to define the self identifier whenever we create the class. One of the good way to define or design your class is using the Unified Modeling Language. We have UML, or Unified Modeling Language. It contains three portions. The first is the class name. So you already know the class name. And then we have the instance variables. In our first example, we have no instance variables. We can say the instance variable is the data member, and we can have methods. So if I separate them into three, yeah, we have person as the class name, and then I have the data members. For example, here I have name and I have age, and I have methods. Let's say I want to get name, I want to get the age, and I want to, yeah, let's say I want to set any information about the name and age. And in this data type, yeah, we want to set name is a string and age is integer. If I want to get name, it means I want to show the name. And then if I want to get the age, I want to show the person age. And if I want to update the person name and the person age, I can use this method. In a class, we can also define a class with parameter, or a class with additional object in the parentheses. For example, I want to make a person with one argument, and the argument is a name. So in order to create this object, we can use the same class name, which is person, but we need to define what is the argument that we want to put. So I can define that I want to put name. Then you have the person names. Let's say this is the P1 and the name is Bernardo, and the P2, the name is Yahya. So the method that you use, still you can use the dot, but it will access to different data. Now let's see. Maybe I don't have this one. Okay, let's make. I have the class person. Okay, and then I still have the def, say hi, and then I want to print how are you. Let me keep blank like this one. So what I can do with the argument is we need to make a constructor. The constructor, I will explain later, we call it the init. And here I need to define the self identifier, and I would like to put one argument. And the argument will be name. How can I put this name? I need to put this name into the identifier cell, and the identifier cell will have a name. So the name that everyone inserted here will go to the variable name in that class. If I save the name into this variable name in this class, so I can print what is the person name. Let's say I have P2 and person Park. And then I want to call P2, and then you can just press tab. When you press tab, you can have two options. The first is name. Name is instance. It means you can check what is the content of the variable name. Or you can call say hi, which is a function. So it is a method. Now let's see, I want to call the method. When it is a method, you need to put the parenthesis. How are you? Ah. In this case, we are calling the statement. Here we want to print how are you, and then we call the variable name that we already saved here. If you want to check the variable name, you can just use dot name, and you will see that it is string, and the string is pub. How can we know that it's pub? Because we define the name pub here. Okay. Yeah, this is the very basic of the object-oriented programming. If you understand this concept, it will be easier to understand the other examples, which is more complicated than this one. Now, you can see that there is a difference with the previous examples. The difference is we can have the additional object, or we can have the additional data. And this data is defined in one constructor. The argument is automatically embedded into the object, but there is no storage to maintain the argument. So that's what we need, the constructor. In any object programming languages, we need to know about the constructor. The constructor means whenever we want to create an instance, we need to have one way to define all the instances. So in this case, I want to create a person, and let me make the attribute name. So this attribute name will be saved into the variable in that class inside of this cell. So if it is the attribute P1, then it will be in the address of the P1. If I define the P2, then it will be saved in the attribute or the object P2. So we have one data member, which is name, and the name is a string, and we have the method, which is say hi. Internally, this results in a call to the specially named init method. So this init method, we call it as the constructor. the init method serves as the constructor of the class. And its primary responsibility is to establish the state of a newly created person object with appropriate instance variables. If you need to have more information about the person, you can put more information here. So when you create an object, you will have many attributes. That's also possible. The data member, the code create a data member name using the self name. The self name here is a variable that you will save it into the variable of this class. And whenever you make a method, there will be one identifier which is self. So this self can find what is the address or what is the memory address of the respective variable. That's why you need to make this self whenever you create a function or a method, because whenever you need to call the attribute, whenever you need to call the variable, you need to put self dot something something something. If it is name, then you need to put the self dot name. If it is address, then you need to put the self dot address. Now, in this example, the person object contains one method and one argument. When we discuss the method, we have the one method and one argument. So this is the method. Whenever we call the data member in a method, we need to include self-identifier. If we have name, then we need to call self.name. If we have address, we need to call self.address. So we can see here that if we let's say we have two objects. Let's say we have two objects, and then there will be two data. So if we call the P1 say hi, then the result will be how are you? What about if I call the P2 say hi, then the result will be how are you? How? Because we have the variable name. So that's what we can learn from the basic object oriented with this example. Now let's make more a complex class. Now I'm going to make one student object and we have more than one argument. The class consists of two arguments in the constructor. So you can see here, we have two arguments in the constructor. And then we have three data members. Here we have student name, student city, and score. You have student name, student city, and score. And let's put the initial value as 0 for the score. The variable score will be initialized as 0 when there is no behavior info. And then you can define another method, which is get student name, get student city, get student score, set student score, and then get student score. Let me make this one. I have class student, and then I will make a new tab in it, which is the constructor, and I have two variables, which is student name and student city. So I want to make 3 data members. Actually, you can have this name different, but let's make the same to avoid some misunderstanding. We can have the student city as the student city, and then I have another variable which is score. So I have 3 different data members, name and the student city, and then score. Now I would like to make another function or method. So I have get student name. So if I want to check what is the student name, then I can have I can just make a return function. If you still remember, the return means whenever you access the method, it will return according to what you call. Okay. So in this case, I would like to get the name. Then it will be a string. Okay, so when you access this one, when you call the name, it will return only the respective name. You can also make a new method. Let's say I want to call the get student city, and I want to get the student city. Okay, so the variable name here should be the same with this one. Now I have another method which is to set the student score. Let's say I have a new score, okay, that I can assign to the student. So I have one identifier which is self, and I need to define what is the variable name. Let's suppose I make the variable name as score. And I want to update the score with the information score in your method. And the last, I want to get the student score. So I have one identifier, which is self, and I want to get later on the respective score. Okay. So this will be the complete class. We have one constructor. We have 4 methods. So I will run this and let me make a new student. Student 1. And let's refer to this student. Let's say I put just name B, and then the person live in Yoin. Okay. And then let me make a new student, student C, and he live in Seoul. Okay. If I want to know the student name, when you press tab, you can have this method. I want to know the student name. So you can just press the get student name and then put the parenthesis. And when you enter, you know that the student name is P. And if I call the object to get student name, put the parenthesis, and I know the name of the second student is C. You can also do the same with the S1, get student city, in, and then the student 2, you want to get the student city, and the student city of the S2 is Seoul. What about the score? If I want to get the score from the student 1, I want to get the score. The score is 0, okay, because the initial value is 0. Now I want to set a new score. When I want to set a new score, I can give a score, let's say 95. So this score means I have one argument, I have one parameter that I can set. And this will be the new value for the variable score. So if I put this one as one set to score 95, and then if I call get to score, the result will be 95. Okay. I will stop here because I think it's the time to do your review quiz.